Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 3, that is the introduction to the SQL language. In the last class we have studied about this chapter. We have covered some topics of the SQL, that is how the SQL language will be used, and now I am going to continue with this SQL part with more concepts of the SQL. Right. And my information first of all goes to the Larry. Larry, I got your assignment. Don't worry, I will get it. All right, Larry. So let's start with the session with the previous class session. Let's start with the session. Or, all right, Larry. So first of all, chapter number 3, that is the introduction to the SQL, that is structured query language. So this is the overview of the SQL query language, that is how to use the SQL and what are the various concepts that is used in the SQL. So we have studied about the SQL query language, that is a language, that is a structured query language, that is also known as the SQL, that is a part of the system in which the user queries the language, in which the user demands for the database or demands the information from the database, that is the SQL, that is the structured query language. It contains various parts like DDL, that is a data definition language, that provides the information related to the structure of the language or structure of the database, like what are the various relations, what are the various tables that is used in this one, how to delete the relations, how to delete the tables, and how to modify the tables, and how to modify the structure of a table that is related to the structure of the table, structure of the relation. Then we have also studied about the data manipulation language, that is what are the data manipulation languages that is used, that provides the ability to query the information, that is how to get the information, how to insert the records, how to fetch the records, how to delete the records, how to delete the tuples, that is rows, and how to modify the tuples in the database. That is a DML, or that is done by the DML. So one is the DDL, then is the DML, then there is the integrity constraint, that is how the integrity will be maintained, then view definition, transaction control, then embedding or embedded SQL in the dynamic SQL, then authorization, that includes the command for specifying access rights for the two relations and views, that is how to use the relations and how to use the different views that is available in the SQL, that is structured query language. So next part is structured or SQL data definition, that is used with the DDL, that is how to use the DDL and why to use the DDL and what are the various languages that is used in the DDL. So the set of relations or the set of we can say the tables that is used in a database must be specified to the system by means of the DDL. So we are specifying the system, we are specifying the databases, we are specifying the rows in the databases that must be specified to the system by means of DDL, that is a data definition language, right? So it also contains various relationship, it also contains various information like the schema, type, integrity constraint, and what are the various values, security provisions. Then there are different basic concepts that is also used like char, varchar, int, small int, numeric, real, double, float. So these are the various basic data types that is also used in the SQL. Then we have studied about the basic schema definition, that is what is the basic schema definition, what is the basic definition of the schema, or what is the main structure of the schema that is used in the database architecture, that is what is the main logical design of the definition, or what is the design of the definition that is used in the schema, right? So we define an SQL relation by using the create table command. So there is a command that is used, that is a create table command for specifying the rows and the columns that is used. And this is one of the example. It is created the table department that contains 4 fields. One is a department name, one is a building, one is a budget, and there is a primary key that is a department name. So there is a primary key that is also available, that is a department name. So this is how the table will be created. So create a table R that contains multiple rows, multiple columns, and it is of different data type. That is the A1 is one of the column, it is of D1 type. A2 is also a column that is of D2 type. In the same way AN and DN type. And there are few concepts that is used, there are few constraints that is used. One is the primary key that specifies that attributes from the primary key for the relation. Then there is a foreign key that specification says that the values of attribute for any tuple in the relation must correspond to the value of the primary key attributes of some tuple in the relation S. That is a foreign key. Then next is the notional. Uh, this is the syntax that is used how to insert the entries, or how to insert the rows, or how to insert the records into the table. That is the insert into instructor. What are the values that is given? There are different values that is given. That is 10211, then Smith, then biology, then 66,000. The values are specified in the order in which the corresponding attributes are listed in the relation schema. The insert command has a number of useful features and is covered in the detailed chapter in section 3.9. And this is the command that is how to use in delete the, or how to delete the student, or how to delete the, we can say, the tuples from a relation. And this is the one of the examples that is given. So we have created, or this book has created the first of all table that is a department, then table that is a course, then table that is a instructor, and then table that is a section. There is a table teaches. So the 5 tables are created. One is the department, then course, then instructor, then section, then teaches. And this is also the method that is used, that is how to drop the table or how to delete the table. This is also a provision, that is we can use the drop table command to drop the table, to delete the table. And if I want to modify some structure of the database, or some, we can add the attributes of a database, that is modification of the relation, modification of the table, that is used by using the alter tab, or alter table command. That is the alter command that is used to alter the table, or we can say the adding the features, adding attributes in the table. Then basic structure of SQL queries, that is what are the basic structures of a SQL queries, in which we are using the 3 clauses. That one is the select, one is the from, one is the where. Select means what are the values, what are the attributes that is selected from the table, and from means the table name that is given, that from which table we are getting the values, and where is the condition, that is what condition we are applied. Suppose we are written that select the names from the table student where employee name or the student name is equals to Ram. So only Ram value, or the name, student name, that is the Ram value, is displayed on the screen. So where and the select clauses are also produced, that produce the relation as a schema. Then queries on a single relation, that what are the various queries that is available on a single relation, single table. This is the select name from the instructor. That is how to, this simply says, or this simply gives the different names from the instructors. Only one table or only one column will be chosen from the table instructor. In the same way, there is a department name from the instructor. So these are the various commands that is also used. Then we have also discussed about how to get the queries, or how to apply the queries on multiple relations. That is, if there are multiple relations that is available, so how to find out or how to apply the queries on multiple relations. This is one of the example. Then select name instructor dot department name building. So getting the name, getting the instructor dot department name, that is the department name from instructor table, then building from instructor department. So getting the department name from the instructor, and the name and the building from the department, where instructor dot department name equals to department dot department name. So whenever the, or wherever the department name of the instructor and the department table is same, so find out the value. So where is the condition that is used, that is where instructor dot department name equals to department dot department name. So getting the value, getting the, or fetching the values from the department name from the, or we can say the department name from the instructor table, as well as the department name from the department table that is used, and select the name as well as the building name as well as the department name from the instructor table. This is one of the results that is available in, that is retrieving the names of all instructors along with their department names and department building name. So what are the various names, or what are the names of all the instructors along with their department names and the department building name? So these are the 3 clauses. The select clause is used to list the attributes that is desired in the result of a query. That is, what are the various attributes, or to list the attributes, or to provide the attribute that is desired in the result of a query. Then from clause, that is a list of the relations that to be accessed in the evaluation of the query, that is from which table it is used in, that is a list of the relations, list of the table that is used in the we can say for fetching the queries. And select clause, that is used to choose the attribute, list the attribute that is desired in a result of a query. Then where clause, that is a predicate that involves attributes from the from clause, that is whenever I want to apply the condition, that is applied by the where clause. This is one of the syntax. Select multiple attributes from different rows or from different relations where P, that is a predicate, where the relation is or where the condition is, that is applied the condition or whatever the condition that is applied. This is these are the all syntaxes example that is also used in this one. Then we discuss about the natural join, that is how to use the natural join, that is how to join the tables. This is the relation how to join the tables. We are providing or we are getting the two columns from two different relations, that is the instructor and the teaches. And how they are combined? They are combined by using the ID, by using their IDs, that is the instructor.id equals to teaches.id. And this query can also be written more concisely or more appropriate manner using the natural join operation in the SQL. So select name course ID from instructor, natural join teaches. So instructor and the teachers are joined naturally, that is the ID of the instructor and the ID of the teaches table is joined naturally, that is a natural join teaches. These are the examples of the natural joins. Then there are additional basic operations also that is available on the design. So how to use the additional basic operation that is used with the we can say the used with the SQL. So this is the today's session. So let's start with a new session, new topic. That is, what are the basic operations or additional basic operations? We have studied about the delete, we have studied about the alter, we have studied about the create. Now what are the various additional basic operations that is used in the that is used with the database for applying the database or to query the database? That is a additional SQL or SQL basic operations, that is additional SQL basic operations. The first one is a rename operation, that is renaming the table, renaming the database, renaming the query. So consider again the query that we used earlier. This is a select name course ID, that is getting the name as well as the course ID from two tables, that is the instructor and the teachers table, where instructor.id equals to teachers.id, that is matching the, or what is the condition, that is the IDs of that instructor and the ID of the teachers are matching, and find out the name and the course ID from two tables, one is the instructor, one is the teachers. And what is the result of this query? That is with the following attributes. That is there is a table that is maintained with two attributes, that is the name and the course ID. The names of the attributes in the result are derived from the names of the attributes in the relation in the from clause. We cannot, however, always derive names in this way for several reasons. Why? What are the various reasons that is not used? First, two relation in the from clause may have attribute with the same name. So whatever we have, whenever we apply the table or whenever we specify the table, so there are some conditions or there are some scenarios where the two relations in the from clause, that is two tables have in the same, or two tables from the from clause may have attribute with the same name. So if they have attribute with the same name, how we are applying or how we are getting the attributes, in which case an attribute name is duplicated in the result. Second, if we use an arithmetic expression in the select clause, the resultant attribute does not have a name. These are the multiple conditions, that is why we are not using the derived name, or why we are not using the derived class, or why we are not using the attribute that is used in the derived class. It uses the adds taking the form. So how to rename, or how to rename the query, or how to rename the operation that is used, that is the old name as new name. So the as clause can appear in both the select and the from clauses. So we can apply this as in both the select as well as the from, that is we can apply on the attributes also, we can apply on the relations, that is the tables also. For example, if we want the attribute name to be replaced with the name, instructor name. So if I want to replace the name with the instructor name, then we can rewrite the preceding query. We can rewrite the query as select name as the instructor name, that is getting the name as the instructor name, or choosing the name as a instructor name. So this takes the name attribute, this takes the name column from the table, that is the instructor, but the name of the column that is changes, or that change from the name to the instructor name. Why? Because we are applying the alias. This is known as alias, alias. That means changing the name. So change the name heading, or change the name column heading to the instructor name. Then course ID from instructor teaches, where instructor.id equals to teaches.id. The as clause is particularly useful in renaming the relations. One reason to rename a relation is to replace a long relation name with a shortened version that is more convenient to use elsewhere in the query. So one of the main reasons to rename a relation is to replace a long relation name with a shortened version that is more convenient to use elsewhere in the query. So this is this is the main reason, that is how to replace with a shortened version, or how to, we can say, the renaming the attribute, that means giving the shorter name or giving the longer name, or giving such name that is very fruitful for the database. To illustrate, we must rewrite the query for all instructors in the university who have taught some course. Find their names and course ID of all courses they taught. So select the T name and the course ID s.course ID. So from the teachers table, there is a name that is chosen, and from the course ID, or for course table, that is a course ID. From the instructor, that is using the table name as the instructor as T. So what is the name of the table that is changes? That is the instructor, table instructor name has been changed to the T, and the table teaches name has been changed to the S. So the instructor as T and the teaches as S. Now what is the condition? That is where the T dot ID. So whatever the ID column that is available, that is of the T, that is the teaches, is equals to the S dot ID. Another reason to rename a relation is a case when we wish to compare tuples in the relations. So these are the multiple reasons why we are using, or why we are changing the names of the columns. So the next is select distinct T dot name, that is a unique value must be find from instructor table, that is given as a name as a T, and the instructor given as a T S. So the table T is an instructor table, and the S is a teachers table. Teachers table. In the next one, there is an instructor table, that is a T. There is an instructor table, that is a S. Now the next one is next additional operation, SQL operation, is string operation. That is, what are the various strings operation in the SQL? That is how the string operations are performed in the SQL. That is, what are the various string operations that is used in the SQL. So SQL specifies strings by enclosing them in a single quotes. For example, computer. A single quote character that is a part of the string can be specified by using two single quote characters. For example, the string it's right can be specified by it's right. There are double quotes, there are two single quotes that is also available, that is a single it's right. The SQL standard specifies that the equality operations on the string is case sensitive. So whenever we apply the equality operation, that is a case sensitive. As a result, the expression computer science is equals to computer science evaluates to the false. So there are multiple conditions, there are multiple comparison, or we can say the whenever we use the strings in the SQL, there is a differentiate between the different characters, there is differentiate between the different symbols, double quotes, so that evaluates to the false. However, some database systems such as MySQL and SQL Server do not differentiate uppercase from the lowercase when matching strings. So whenever they match strings, that they do not differentiate, they do not apply the case sensitiveness, but this SQL that is a MySQL or the SQL server or SQL, differentiate between the lowercase and the uppercase. SQL also permits a variety of functions on the character string. So we can apply the various functions of the character strings such as concatenation, that is concatenate means merging the strings using the two symbols, extracting the substrings, finding the length of the strings, converting the strings into the uppercase, that is finding the uppercase letter, or simply a string is given in a lowercase, I want to find the in a uppercase letter, that is also applied. Using the function upper where s is a string and the lower case where the function lower is used. Removing the spaces at the end of the string using the trim. So there is a function that is upper that we can say that makes the string in uppercase, then that converts the string into the uppercase, then lower function that makes or converts the string from the uppercase to the lower case, and then removing the spaces by using the trim function. That is, there are so many functions that is available. This is one of the example, that upper, lower and the trim. And this is also one of the important, that is pattern matching can also be performed on the string using the operator like. So whenever I want to perform the pattern matching, that is also performed by using the strings by using the operator that is a like. Which describes the pattern by using the two special symbols. So there are two special symbols that is available that is used to match the pattern, that is a pattern matching. The first one is percentage. So we use the percentage. Second one is underscore. So either we can use the percentage, either we can use the underscore sign that is used to specify or that is used to perform the matching patterns, right? So one is the percentage sign. The percentage character matches any substring. So if I want to find out any substring, if I want to match the substrings that is used with the percentage, then the underscore character matches any character. So percentage is used for the whole string and single underscore matches any character. So there are two concepts, one is a percentage, one is a underscore. And next line says patterns are always case sensitive, that we cannot apply on the uppercase, lowercase at the same time because they are case sensitive. This is intro percentage matches any string beginning with the intro. This means any string that is available, but the starting 5 characters are the intro. So this matches any string that is beginning with the intro. Then again next is there is a percentage, then comma, then there is a percentage. That is matches any string that makes the or that have a or that contains the comp as a substring. So that makes the substring or that makes the any string as a substring that is also available. So this is comp. There is a percentage sign at the beginning, there is a percentage sign at the end. So percentage sign at the beginning means we can find any string at the beginning, but the main thing is that there is a substring that is available in the comp as a substring. So first of all, any characters are placed, then there is a comp, then after that comp there are n number of characters that is placed. The condition is that there is a comp character that is available as a substring. For example, introduction to computer system or computer science that is available, that is also a case of the introduction to. This is available with the first percentage, that is a left side percentage, and the after p, that is a UTER, and the sign that is available with the next percentage. And the next is computational biology, that is also a thing, that is computational, comp is available, and after that there is a utational and the biology. There is also space that is also available. Now this is dash 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 that matches any string of exactly 3 characters. That matches any string of at least 3 characters. This is exactly 3 characters. So whenever we use the dash dash dash, that is the exact 3 characters. When we use the percentage, that is any string of at least 3 characters. SQL also provides the like comparison operator or the like operator. This is or it is using the like operator. So select the department name from department where building like Watson. So select the department name, or what is the column name that is given, that is a department name from the table department where building is like percentage, Watson, percentage. So whatever what's the building name that starts with the, or that has a substring that is available with the Watson. Any characters that is available at the beginning and any character that is available at the end. But there is a substring that is available in the as a substring that is a Watson. So this query is used to find the name of departments whose building name includes the substring as a Watson. This is given over here. Find the names of the department whose building name includes the substring that is a Watson. For pattern to include the special pattern, we are using the percentage sign, we are using the escape symbol, we are using the multiple symbols. Now, attribute specification in the select clause. That is, what are the various attribute specification in the select clause. So the attribute specification in the select clause, that is a asterisk, that is simply a multiplication sign that can be used in the select clause to denote all attribute that is available. That is, there are 4 attributes, for example, that is available. So this is used to denote the all attributes, that is the asterisk. So if I want to find every attribute, we can say every column that is used with the asterisk sign, that is used with the multiplication sign. So the asterisk can be used in the select clause to denote all the attributes. Therefore, the use of instructor, then dot, then star in the select clause of the query. That is, select instructor star from the instructor teaches, where instructor ID equals to teaches ID. So select the instructor, that is the instructor column from the table instructor and the teaches, and where the instructor ID, that is matching the ID of the ID from the table instructor with the ID of the table teaches. That indicates that the attributes of instructor are to be selected. A select clause of the select star that includes all the attributes of the result relation of the from clause are selected. So every attribute of the instructor table will be used, or will be given as a majority, will be given as a, or will be available, or will display the available result, or display the attributes as a result. Then next is ordering the display of the table. That is, there are different order that is also available to display the tuples, to display the various we can say the rows. By default, the order by clause is list items in ascending order. So if I simply give order by name, that is, it display, or it gives, or it, we can say, the sorted the order, that is, it provide the sorting by the name. So SQL offers some control over the order in which the tuples in a relations are displayed. So there is also a provision to display the tuples in a various order, in a various, we can say, the manner, that is either in the ascending order or in the descending order. The order by clause causes a tuple in the relation of a query to appear in the sorted order. So the order by is used to appear the things, or to appear the result, or to make the things in the result of a query to appear in a sorted order. To list in alphabetic order all instructors in the physics department, we write. So if I want to display instructor order, or if I want to display the alphabetic order, all the instructor, that is the name of all the instructor in the alphabetic order in the physics department, we write select name from instructor. So select the name field from the instructor table where department name equals to physics, that is the name of the department is physics, order by name. By default, order by name provides we can say the sorts attribute within the ascending order. So this sorts the name within the ascending order, that is the name will be sorted with the use of the alphabetic keys. That is, first of all, the A characters, a character word that start with the A will display, then B, then start with the B will display. That is, the order by clause is used. And if I want to display them in a descending order, that is my requirement. So if we use the word that is a DESC, that is a descending, to display the content, to display the attribute, to display the columns, to display the, we can say, the attribute, that is the columns headings within the descending order, that is a DESC is used. So this is select star, that is select every field from the table instructor, order by salary descending. So this gives the salary, or this display the salary in a descending order and the names in the ascending order. So display the salary in a descending order and display the names is an ascending order. Then there is a where clause predicates, that is a where clause, how the where clause will be used. So SQL includes a between comparison operator to simplify where clauses that specify a value will be less than or equals to some value. That is, a where clause is used that specify whatever the value, or what's the value that is less than or equals to some value and greater than or equals to some other value. If we wish to find the names of instructors with salary amount between 90,000 and $100,000, we can use the between comparison. That is, we can use the between to identify or simplify the where clauses, that if I want to find the gap, or if I want to find the values between two ranges. So this is used with the range. So this is a use, that is select name from the instructor where salary lies between the 90,000 to the 100,000. Instead of writing this query, that is a less than 100,000 and greater than 90,000, instead of writing this one, we are using the between clause and the and word. So simply we can use the not between comparison operator. SQL permits to use the or us to use the notation to denote a tuple of a tree and containing v1, v2 and the vn. The comparison operator can be used on tuples and the ordering is defined lexicographically. For example, a1 comma a2 is less than equals to b1 comma b2. The C1 relation that is obtained that lists the courses that is taught in the fall 2009. So this is CS 109, 101, then CS 347, then PHY 101. Now, what are the various SQL operations that is used? That is the additional SQL operation, or we can say the new SQL operation that is used. That is used with the set operations. So this says the SQL operation, that is a union, intersect and the except operate on the relations. So there are three SQL relations that is used, that is a union, then intersect and the except operates on the relations and the correspond to the mathematical set theory, that is a union, then intersect, then except. So these are the symbols of these three values, or three, we can say the operation, that is a union, intersect and the except. We shall now construct queries that involves the union, intersect and the except operations over two sets. The set of all courses taught in the fall 2009 semester. To select course ID from the section where semester equals to fall and the year equals to 2009. So select the course ID column from the table section where semester value equals to fall. So what is the value of the, or what's the we can say the attribute that is given of the semester, that is a fall value that is given, and the year that is given as a 2009. So in 2009, whatever the semester, that is a fall semester, display the value of the fall semester as a course ID and from the table section. The set of all courses that is taught in the spring 2010 semester. Select course ID from the section where semester equals to spring and the year equals to 2000. This is the spring, and this is the semester, and this is the year. In our discussion that follows, we shall refer to the relations obtained as a result of the preceding queries as the C1 and the C2 respectively. This is one of the table that is used, that is displayed with the use of the course ID. That is the C2 relation that is used, that lists the courses that is taught in the spring 2010. So let's start with the first operation, that is a union operation. That is, what is the meaning of, or how to use the union operation, or how to combine the different values. So to find the set of all courses that taught either in the fall 2009 or in the spring 2010 or both. So if I want to find the courses that it taught in either 2009 or either in the 2010 with the, we can say the, with the season, with the semester, that is the fall and the spring, then we write select course ID from section, that is select the course ID column from the section table where semester equals to fall and year equals to 2009. Then union, that is merges select course ID from the section, that is again selecting the course ID attribute from the section table where semester equals to spring. Now the name of the semester is string and the year is 2010. So it is merging the two tables, it is merging the two content, that is a spring season or spring semester and the fall semester, and the year is 2009 and the 2010. So merging all the values or merging the spring or merging the, we can say the SQL queries by using the union operation. Union operation automatically eliminates the duplicate. This is one of the important line, that it automatically eliminates the duplicate. It does not take the duplicate columns, duplicate values, duplicate attributes. No, this is not like the select clause. Therefore we are using we are using the union function to operate on the different values. If I want to retain all duplicates, we use union all. That is a union is simply used that avoids the duplicate, and union all is used to we can say that to include the duplicate so that the duplicate values can also be used. The number of duplicate tuples in the result is equal to total number of duplicates that appear in both C1 and C2. This is the course ID that is given, that is a CS19, that will be listed twice, so this will display twice. Now next is intersect operation. We can say the intersect means comparing the two values, whatever the value that is new, that is displayed. So the value that are matching, that will not be displayed, or value that are matching, that will be displayed, and that are not matching, that won't be displayed. So to find the set of all courses, so find the set of all courses that is taught in the fall 2009 as well in the spring 2010, we write. So if I want to find all the courses that is taught in the 2009 semester or 2009 year in the fall semester as well as in the 2010 and the spring semester, so we write select course ID from the section. So select the course ID from the, we can say the from table section where semester equals to fall and the year equals to 2009. Then intersect select course ID from the section where semester equals to spring and the year equals to 2010. So this gives you or tell you the all the courses that is available that is taught in the 2009 fall 2009 as well as in the spring 2010. So this select course ID from the section, that is select the or getting the course ID column from the section table where semester equals to 4 and the year equals to 2009. That intersect course ID, that select course ID from section where semester equals to spring and the year equal to 2010. So this intersect will be used, that is used with the basic thing. The result relation that is shown in figure 3.12 contains only two tuples with CS101. This is the example. This is the figure 2.1, 3.1, that is contain only one tuple with the CS101. That is only one tuple is used that that have ID, that have a course ID, that is the CS101. The intersect operation automatically eliminates the duplicate. So whenever we use the intersect operation, that automatically eliminates the duplicate, only gives the unique values. For example, if it were the case that 4 sections of ECE 101 were taught in the fall 2009 semester and 2 sections of ECE 101 were taught in the semester 2010 semester, then there should be only one tuple with ECE 101 in the result. So whatever the course ID that is available, that is that is only providing the one that does not take the duplicate, that eliminates the duplicate that is available. And if we want to retain all the duplicates, again we are using, or we must write insect all in place of the intersect. So if we use the in intersect all, that is also retaining the duplicates, also providing the duplicates, or also including the duplicates. This is select course ID from the section where semester equals to 4, intersect all. The number of duplicate tuples that appear in the result is equal to the number of duplicates in both C1 and C2. So the union is finished, the intersect is finished. Union means combination of all the values. Intersect means refining the values. Whatever the value that is not common in these one, that will be displayed, that is the intersect. Now next is the except operation. So if I want to find all the courses that were taught in the fall 2009 semester but not in the spring 2010 semester. So if I want to, we can say discard anything, then we use the except operation. So whatever the if I want to find the courses that is taught in the fall 2009 semester but not in the spring 2010 semester, then we write select course ID from the section, that is select the course ID attribute from the section table where semester equals to fall and the year equal to 2009. That is the semester is equal to fall, that is the semester name is fall and the year that is available is 2009. Except, that is what's the content that is not required, that is the spring 2010. Select course ID from the section where spring equals to, or semester equals to spring and the year equal to 2010. So result of this query is available in figure 3.13. This is available, that is the course ID and the next course ID. Note that this is exactly relation C1 of figure 3.9, except that there are tuple that does not appear. The except operation output all the tuples from its first input that do not occur in the second input. So it gives the tuples, it gives the rows from the first input that is given. It does not give the rows from the second input or the second table. That is, it performs the set difference. So whatever the rows that is available in first column and the second column, it provides the rows from the first column only, then that is not provided by the next column or the next table. The operation automatically eliminates duplicate in the inputs before performing the set difference. Automatically the operation, or automatically it eliminates the duplicate in the inputs before performing a set difference. So automatically eliminating the duplicate values whenever the duplicate values are available. For example, if 4 sections of ECE 101 were taught in the fall 2009 semester and 2 sections of ECE 101 were taught in the spring 2010 semester, the result of the except operation would not have any copy of the ECE 101. If we want to retain the duplicate, that is, if I want duplicate the same concept, then we use the except all in place of the except. So whenever we use the we want the duplicates, then use the ALL all function with the operation, that is, for example, union all, for example, intersect all, for example, except all, that is used with the basic operations. Except all means also including the duplicates value. The number of duplicate values of a tuple in the relation is equals to the number of duplicates of the in C1 minus the number of duplicates in C2, provided that the difference is positive. Now these are the various basic operations, or we can say the additional SQL operations, that is a union, intersect and the except. Now next is the null value, that is what are the various null values that is available in the SQL query language, that is the null values. So that is a 3.6. So first take a break, then moves to this function or moves to this topic, that is what are the various null value that is available. So let's take a break right now, then moves to next topic, that is the null values. Let's take a break. Come back from the break. Now let's start the session again. So the next topic is null values, that is what are the null values, or what is the meaning of null values, how the null values are beneficial, or in which place the null values are used. That is the next topic, that is the null values, right? So null values are or present special problems in relational operations. So this provides the special, or this presents the special problems in the relational operations, including arithmetic operations, including comparison operations, and including set operations. There are three kinds of operations that is contained in the relational operation, that is a arithmetic, that is a comparison, and that is a set operations. So the result of an arithmetic operation that involves the plus, minus, divide, multiply, that is the addition, subtraction, division, multiplication, then is null, and if any of the input value is null. So whatever the or any of the input value that is provided is a null. For example, that is if and only if what is the value of the null, if and only if the input values is null. So if any input value that is available is the null, then the output that is also given in the null. For example, if a query has an expression r dot a plus 5 and the r a is null for a particular tuple, then the expression that is a result must also be a null for the tuple. So if any of the input is a null in case of the arithmetic operation, in case of the comparison operation, then the output that is available is, then the result that is also available could be also be a null for that tuple. Comparisons involving nulls are more of a problem. So if there is a null value that is used in the comparison operators, that is a we can say, or that involves a problem, or that makes a chaos among the problems. For example, consider the comparison 1 is less than null. It would be wrong to say that it is true, since we do not know what the null value represents. But it would likewise be wrong to claim this expression is false if we did not 1 is less than null, but evaluates to true, which does not make sense. SQL therefore treats as an unknown the result of any comparison involving a null value. So SQL therefore treats a null value that is also available, that makes the unknown value that is available as a null value that is not null, and the null values. Then that is the comparison operator provides two values, that is a true and the false. Since the predicate in where clause can involve boolean operators as or and or not the comparison, the definition of boolean expressions or operations are extended to deal with the value unknown. Now these are the three expressions that is used with the boolean operations that is used, that is the and or not. And means both the conditions are satisfied, otherwise the value is false. Or means either one of the input is correct, then the value is true, otherwise the value is false. Then not means the result of not unknown is unknown. Then and is the result of true and unknown is unknown, false and unknown is false, while unknown and unknown is unknown. So whenever we are taking the unknown and the true value, the output is unknown. Whenever we are taking the false and unknown, that is also the output is false. While the unknown and the unknown, the value is unknown. In the same way, in the case of OR, the result of the true or unknown is a true. Any of the input is true, then the true. The false or the unknown is unknown, and unknown or unknown is unknown. That means any input, if it is available to you, then the output is true. Otherwise, the output is either unknown or false. Then note that is the result of note unknown is unknown. You can verify that if R is A dot null, then A is less than RA, as well as note A is less than RA evaluates to unknown. Then there are different aggregate functions that is used with the SQL, that is the aggregate function. So aggregate functions are the functions that takes a collection of values. So if I combine multiple values together, that is the aggregate functions. So that are a function that takes a collection, or we can say the set or multiset of the values as an input and returns a single value. So this takes the values as an input and then returns only a single value. SQL offers 5 built-in aggregate functions. There are total 5 built-in aggregate functions, that is a predefined aggregate function that is available. First is the average, then minimum, then maximum, then total, then count. So these are the 5 functions, 5 aggregate functions that is available with the SQL. Now what are the 5 available functions? One is the ABG, one is the minimum, that is the min function, one is the max function, one is the sum function, one is the count function. The input to the sum and the average functions must be a collection of the number, but the other operators can operate on a collection of non-numeric data type. So this average and the sum function will take the input as a numbers, that is the digits that is available, but other input can take other values also, that is a collection of non-numeric data types also, such as strings, such as values, such as characters, anything that is used. So first is basic aggregation, that is how to find the average. So consider the query, find the average salary of instructors in the computer science department. So if I want to find the average salary of the candidates that is available in the computer science department. So first of all, aggregate the computer science department, or first of all apply the condition on the computer science department. So this says select the average salary. So AVG is a function that is used. Uh, we are finding, or we are applying the average function on the salary. So this is select AVG, then salary from instructor table where department name equals to computer science. The result of this query is a relation, is a table with a single attribute. There is a single attribute that is available, that is a salary attribute, because we are taking, or we are applying the select average salary. That is only we are applying the condition, we are applying the aggregate function on only single value or single attribute, that is a salary attribute. So this provides a relation, this provides a table with a single attribute containing a single tuple with a numeric value corresponding to the average salary of the instructors in the computer science department. The database system may give an arbitrary names to the result relation attribute. So this gives an arbitrary name that is available to the result relation attribute that is generated by the aggregation. However, we can also give a meaningful name to the attribute by using the as clause as follows. So we can also give the alias name. We can also change the name of the attribute by using the as clause. So this is select AVG salary. So select the we can select the column, that is provide the column that is the AVG salary, that is calculating the AVG salary as AVG underscore salary, that is using the alias name, using the column name, that is the AVG underscore salary from the instructor table where department name equals to computer science. So select the AVG salary as the AVG salary, that is the AVG underscore salary is the name of the, we can say the name of the column from the instructor where the department name equals to, where the name of the department equals to computer science. In the instructor relation of figure 2.1, the salaries in the computer science department are 75, 65 and 92. The average balance is around this one, that is a 77,333.33. Retaining duplicate is important in computing an average. Suppose the computer science department adds a fourth instructor whose salary happens to be 75,000. This is one of the examples. Suppose if duplicates were eliminated, we would obtain the wrong answer, that is 232 then divided by 4, that is 58,000, rather than the correct answer of 76,750. There are cases when we must eliminate the duplicates before computing an aggregate function. There are some cases in which the duplicate functions are not required to apply on the function, whether this is the aggregate function, whether any function that is used that is related to the numeric value or that operates on the numeric value like sum and the average. So it is not required to, or it is not we can say the fruitful or worthy or to use the duplicate value, because when the duplicates values are again added, that also provides some high value, or that also increases the value. So there is a need to eliminate the duplicate, that is only provided by using the SQL, by using the SQL query language, by using the distinct keyword. So there is a keyword that is available, that is a distinct, that is DISTINCT, that is a distinct. So what's the value, what's the, we can say the query, select count, that is the count function is used, then distinct ID, that is the ID or the distinct keyword is applied on the ID. So the ID can contain the distinct keyword. So the ID is separated, or ID is taking only the non-duplicates values, and the count function is used, and the table name is teaches, their semester equals to spring and the year equals to 2010. That is the semester that is available is the string, spring, not the string, that is the spring, and the year that is available is 2010. Because of that keyword string preceding ID, even if an instructor teaches in more than one course, or even instructor teaches more than one course, she is counted only once in the result, because there is a distinct ID whether they are applying for the more than one course, whether they are applying for a single course. We can also use the aggregate function count frequently to count the number of tuples in a relation. So if I want to find the number of rows in a relation, that will be counted by using the count function. The notation of this is the SQL is count asterisk. So if I want to find the number of tuples then we use the count, and there is a asterisk sign, because asterisk is used for calculating the, we can say the calculating the whole table, or whole rows and the columns of the table. So whenever we use the count star or count asterisk, that means we are using the, or we are counting the total number of columns, total number of tuples in a relation. Therefore, to find the number of tuples in the course relation, so if I want to find out the number of tuples, number of rows in the course table or course relation, then we write select count asterisk from course. That is a count is applied on the each and every tuple of the table course. So this is the ID, this is the name, this is a department name, this is a salary. This is the ID, that is 76766. Name is Craig, department name is biology, and the salary is 72,000. That is counting the function. This is another ID that is contain different, we can say the names, and the department is the computer science department, then electric engineering. The tuples of the instructor relation grouped by the department name attribute. SQL does not allow the use of distinct with the count function. So whenever we use a count asterisk, that is not used with a distinct function, so distinct keyword. It is legal to use a distinct with the max and the minimum function, even though the result does not change. We can also use the keyword ALL in place of the distinct to specify the duplicate retention. But since all is a default, there is no need to do so. Now, how to aggregate with the grouping, that is how to use the group by clause, or what is the usage of group by clause. So this says there are some scenarios, there are some circumstances where we would like to apply the aggregate function not only to a single set of tuples, but also to a group of set of tuples. We specify this wish in a SQL using the group by clause. So whenever I want to specify group of set of tuples, so whenever we combine multiple tuple, that is a set of tuples, then we use the group by clause. That is, group by means grouping among the different clauses, grouping among the different tables, grouping among the different tuples, grouping among the different attributes. So we can specify the group by clause. The attribute or the attribute that is given in the group by clause are used to perform the groups. So the group by clause that is used to group the, or that is used to form the groups. Tuples with the same value on all attributes in the group by clause are placed in one group. Now, as an example, find the average salary in each department. So find the average salary in each department. We write the query as follows. So whenever I want to find the average salary in each of the department, select department name, then AVG salary as a AVG underscore salary from the instructor table, that is grouped by the department name. So select the department name, that is a column that is displayed is the department name, and the next column is AVG underscore salary from the table instructor, that is grouped by the department name. That is grouped by the that is a group by clause is used, that is we can do the grouping, that is grouped by the department name. Figure 3.14 shows the tuples in the instructor relation, that is grouped by the department name. This is grouped by the department name. One is the biology department, then computer science department, electric engineering, then finance department, history department, music exam department, and the physics department. So these are the multiple departments that is grouped by departments. So this is one of the example, that is select the department name and the average salary from the table instructor, where the grouping is done on the department name. This specified or the specified aggregate is computed for each table, and the result of the query is shown in the figure 3.15. This is again the query, that is only display the department name and the average salary. One of the department name is biology, because this is grouping, so only one name will be available and the average salary is available. So find the average salary of different persons, that is 72,000. Here this is the combination, or find the average of these three values, that is 75, 62, 92. This is the average of these three values, that is 72, 62, 92. Then electric engineering, that is 80,000. Then finance, there is a 85,000. That is 90 plus 80, that is a 14. sorry, not 1 4, that is a 117 that is divided by 2 that provides the value as a 85,000. This is the 117 divided by 2, that is a 85,000. There is a history, that is a history department also, that is also the average salary, that music, then physics. In simple terms, find out the names or display the names of the departments that contains the average salary, that find out the average salary of the different departments. Suppose computer science has 3 values, finance has 2 values. So adding the 2 values and then divided by 2 or 3, whatever the count of the value that is available. That is the average salary, and the name of the, we can say the name of the column heading is AVG underscore salary. So this figure shows a tuple in the instructor relation that is grouped by the department name, which is the first step in computing the query result. The specified aggregate is computed for each result, and the result of the query is shown in this one, this one, this one. Now in contrast, if I want to consider the query that is find out the average salary of all the instructor, that is find out the average salary of all the instructor that is available. So we write this query as follows, that is select AVG salary from the instructor, that is average, that gives the average salary of all the instructors. In this case the group clause is omitted, so the entire relation is treated as a single group. So this will display the entire salary from the table instructor. Another example of aggregation on group of tuples, consider the query that is find out the number of instructions, that is find out the number of instructions that is available or instructors in each department, that is there are n number of instructors that is available in each department who teaches a course in the spring 2010 semester, that is also available, or that is, so find out the names of the or number of the instructor, that is there are total number of instructor that is available, that is a count of the instructor that is available, that is a count that is also available in the instructor that is in each department who teaches a course in the spring 2010 semester. That is what is the 2010 semester teaches, or whatever the value that is available in the 2010 that is also available. So information about which instructor teach which course in which section, that is also available. So information about which instructor teaches which course, which section in which semester, that is available in the teachers relation. However, this information has to be joined with information from the instructor relation to get the department name of each department. Therefore, we write the query as follows. So what is the query name that is available? That is select department name, then count distinct ID, that is count the IDs, that is a distinct ID as an instructor, or the INSTR count, that is the column name is INSTR underscore count from the instructor table that joins with the teaches, where the semester equals to spring and the year equal to 2010, that is grouped by department name. The result is shown in the figure 3.60. This is the department name and this is the instructor count. That is a count the distinct value of the department. There are 3 computer science departments, so the value is 3. There is a 1 finance, history 1, music 1. This is nothing but the group by clause, that is how to group the various values, how to group the different attribute that is available. Next is having clause, that is whenever we use the group by clause, next clause is having clause, that is also providing the condition, that is also used for the condition, that is a having clause. So at times it is useful to state a condition that applies to a group rather than to the tuples. That is there are some scenarios, there are some, we can say the situation that is used to state a condition that is applies to a group. So if I want to apply a condition that is applies to a group rather than a tuple. So if I want to apply the conditions on a group that is formed using the group by clause, then we use the having clause. For example, we might be interested in only those departments where the average salary of the instructors is more than the 42,000. This condition does not apply to a single tuple, rather it applies to each group constructed by the group by clause. To express such a query, we use the having clause of SQL. SQL applies a predicates, or SQL applies a condition in the having clause after the groups have been formed. So once the groups have been formed, then we use the having clause to use the, or to provide the condition in the group by clause. So the aggregate function may be used. We express this query in SQL as follows. So how to use the having clause, or how to get the having clause, that is as follows. So select department name avg salary h avg underscore salary. So select the department name, select the avg salary that is available, that is the average salary that is available, that is given the name, that is the avg underscore. So this is the having clause that is used, that is how to group the, or how to make the grouping on the basis of the group by clause, or how to apply the conditions on the group by clause. So this is select department name average salary as average salary from the instructor, that is grouped by the department name having average salary is greater than 42,000. That is the average salary is more than 42,000, that is also available, that is applying the conditions on the group by clause. This is one of the example, that is the physics, electric engineering, finance, computer science, biology, history. That is the result of this one. Now next is how to use the aggregation with the null and the boolean values. That is how to use the null and the boolean value that is used. So this is null value when they exist, complicate with the processing of the aggregate operators. For example, assumes that tuples in the instructor elements or relation, or tuples in the instructor relation have null values for the salary. Consider the following query to total all salary amounts. So select sum salary from instructor. So select the sum, or select sum salary, that is find out the sum of the salary, that is the aggregation of the salary from the instructor table. The assumed the value to be summed in the preceding query including the null value, that is also taking the null value, since some tuples have a null value for the salary. Rather than say that the overall sum is itself null, the SQL standard says that the sum operator should ignore null values in the input. In general, aggregate functions that treats null according to the following rule. All aggregate functions except the count asterisk ignores the null values. So whenever we use the count asterisk, it takes the null values. Otherwise, every value does not take the null values. And the Boolean expression also gives the output as a true, false, or the unknown. Now next is the nested subqueries. That is the next topic, that is how to nest the queries, or how to use the one select within the another select, like this one. One select within the another select. That is the nested subquery that I am going to start in the next class, because this is a theoretical topic, so it's not to take more topics, and there is no understanding level, understanding conditions. So that's all for today's session. Thank you so much everyone for listening me. If there is any doubts, any confusions, you can ask the doubts from me, and in the next class I am taking you a next topic, that is the nested subqueries. That is the nested subqueries means query, internal query, or one query is placed inside another query. That is a query, another query, that is a subquery. That is a nested subquery. One query will be used, one select will be used within another select, or one having will be used within the other having. One group by will be used within another group by. That is a nested subqueries. All right. So that's all for today's session. Thank you so much everyone. Any doubts, any confusion, you can clarify from. Thanks a lot everyone. Bye bye. Practical sessions of on SQL that is not a part of the, we can say, the database right now, because right now we are understanding what is the concept, what is the logic behind that, and these various subqueries are detailed in a we can say that these are all used in the, or we can study in detail in the part 3. That is also a full-fledged chapter. Then we discuss the practical part. Don't worry, I will discuss the practical part also. So thanks a lot. Bye bye everyone. All right, Larry.